Okay, now for question 4b, I'm going to have y equals -3, 1.6. I'm going to split it up. So again, that is split up to x over 2 minus 2. And that is by product law. Meaning if I have y equals -3, I'm going to be able to split it up. So I have 1.6 x over 2 and 1.6 -2. And that is due to the product law. Meanwhile, as a next step, I'm noticing that my x over 2 can also be split up by power of a power law. So I'm first going to bring that 1.6 to the exponent -2 to the front so it can become part of the a value. So I'm going to have 1.6 to the exponent 1 over 2 square bracket to the exponent x. So all of that is due to the power of a power law. So as the next step, I get y is equal to approximately -1.17. My b value is 1.26 to the exponent x. And so I'm going to be able to say that is my a value, this is my b value. Meanwhile, there was no c value. So what does that mean? Well, there's a negative there, and there's also a 1.17 as my vertical stretch. So I'm gonna write there's a vertical stretch because my a value is larger than 1, and there's also a reflection along the x-axis. Meanwhile, the 1.26 suggests that there's a growth. And finally, this suggests that the horizontal asymptote is at y equals 0. Okay, so for my original parent graph, I'm going to have y equals 1.26 to the exponent x. So generally, it has a y-intercept of 1 because 1.26 to the exponent 0 is 1, and generally it's a growth. It's an exponential that is showing that there is a growth, and that is my parent function. And this has a horizontal asymptote of y equals 0, and that does not change because there were no shifts up or down. Meanwhile, because the a value is negative, what that means is that instead of having a growth like this, there's a reflection along the x-axis, so it's going to flip over like this. Meanwhile, the 1.17, I need to also consider that as well, meaning that I am going to draw my scale, and so my distance between my horizontal asymptote to my new y-intercept must be so that it has a value of 1.17, negative 1.17. And so when I draw my new transform function, I have a horizontal asymptote y equals 0, but remember I have a reflection along the x-axis, and so the shape of my graph is going to look like this, and not like that, although you might be tempted because it's a growth, but this reflection along the x-axis will make it look like there is a decay instead. Therefore, this is my transform function. And now for question C, I have y is equal to negative 0.5, 4 to the exponent 6. This can be split up, so it's 4 to the exponent 3x plus 8, and that is again by product law. So I have y equals, well, all of this is going to be my a value, and that's equal to negative 2048 on the dot. Meanwhile, I have another power of a power law going on here, which is this, and I'm going to highlight that as green just to indicate that I use my power of a power law. And so when I sum that up, I have y equals negative 2048. 4 to the exponent 3 is equal to 64 to the exponent x plus 8. All right, so for my a value, So for my A value, I have a vertical stretch because it's clearly a value that is larger than 1 if you only look at the scale, the value itself, the number, and ignore the sign because I consider that the sign anyways when I talk about my reflection. And so I'm also going to write reflection along the x-axis. And lastly, I have, well, this is also has a meaning of distance from y-intercept to HA. Meanwhile, for my 64, that's my B, and that is a growth because it's a value larger than 1. And finally, for my C, that is my horizontal asymptote, and my horizontal asymptote is at y equals at 8, which means there has been a shift up by 8. I'm going to start drawing my parent function, which is y is equal to 64 to the exponent x. And so I have my y-intercept of 1, and there's a fast growth of and so there's an exponential growth, and this is represented by this parent graph. And meanwhile, there's a horizontal asymptote of y equals 0. So that is my parent graph. And meanwhile, I have my new graph. And I need to make sure my horizontal asymptote is at y equals 8. All right, so when I'm drawing my new transform function, so what I need to notice is that the distance between my horizontal asymptote to my y-intercept has to have a distance of 2048. And I know that the distance will be under because there's going to be a reflection compared to that parent function. And so my new graph will have a y-intercept instead, negative 2040. How did I get that value? I did negative 2048 plus 8 to get that value. And again, remember that you have your original parent function, but you have a reflection along the x-axis, and so see how it's going to look like this. And so I have to make my graph so that it goes through this y-intercept. It has a horizontal asymptote at y equals 8, and so this is going to be my transformed graph. Okay, so for question 5, it says describe what transformations must be done and in what order for the function y equals 2 to the exponent 4. Question 5, describe what transformations must be done and in what order for the function y equals 2, bracket 4.5 to the exponent x plus 1 to become the following. And so just as like an FYI, I have a kind of print screened some previous topics from Unit 1. So the transformation table of values and the A, K, and DC. So in case you need to kind of follow along that way. So let's start with the original function. So I'm noticing that the A value is equal to 2, the B value is equal to 4.5, the C value is equal to 1. So what does that mean? Well, there's a vertical stretch initially. Then there's the parent function generally has an exponential growth to it. And meanwhile, there is a shift up according to my C equals 1. So that is what I've gathered. Okay, so this is my original graph. Now I'm going to go to my transformed version that I want to eventually get to. So I have, well, I'm gonna need to separate this so it doesn't look so complicated, meaning I have my 4.5, but I'm noticing that I have a greatest common factor between my exponents. And I'm gonna grab that negative 3, and when I do that, I'm going to get negative 2 plus x. I can rearrange that to be 4.5, negative 3 bracket x minus 2. From that, although it might not be our preferred, I can see my A, K, D, and C. So my A value is just going to be a 1. There's nothing being done to it. That's like no vertical stretch. And then for my K, I'm seeing there's a negative 3. So this is the horizontal compression, and remember that is what the function is being multiplied to, and that is my k value. And so this means that there is a reflection along the x-axis, the y-axis, and meanwhile, it also means that there is a horizontal compression. And I know that because that's just kind of like the rule of thumb. I have my k value, and as long as that value is larger than 1, we said that there's a horizontal compression. And that's why I put this on this side so you can go back to it. And meanwhile, for the d value, I have a shift to right, a shift right by 2. Thing added to it, so I have a 0, so there's no shift up or down. Okay, so first I'm gonna start doing, I'm gonna try to undo some of these operations, and then I'm gonna try to put these transformations. So my first step is, well, I need to work backwards, and it's kind of like BEDMAS backwards, which means that you have to deal with addition subtraction. And so that means I'm gonna try to get rid of that shift up. Well, to get rid of shift up, I have to shift down by 1. Instead, well, I need to get rid of that vertical stretch, so I'm going to do a vertical compression instead. So by doing step 1 and 2, I am removing the above the transformation on the right. 3, well, I need to now apply some of these transformations, and I'm gonna do it BEDMAS forward, because it's like you're solving it and you're applying it, so you're gonna go left to right, BEDMAS forward. And so that means I'm going to do a reflection along the y-axis and apply the horizontal compression. I just want to do my shift right by 2 as is. I'm applying the new ones, and my shifts are last because I'm doing BEDMAS forward, meaning doing the multiplication division first, and then I'm doing addition and subtraction. So shifts are last. That concludes how you do question 5.